So translations we looked at, moving a graph left, right, up, or down. That's kind of one of the most important things you need to know in this unit. But then reflections also happen, and we've kind of seen that already. If there's a negative in front, it's upside down, and if it's positive in front, it's kind of right side up. And so that's a reflection about the x-axis. You can also reflect something around the y-axis too, and we're going to look at that here. But here's how you, in general, reflect things. If I have f of x and I want to reflect it about the x-axis, I just multiply the whole thing by -1, and it flips it around or reflects it across the x-axis. If I have something and I want to reflect it around the y-axis, so if I have this V shape over here, and I want it to end up over here, then I only change the value of x. I put a negative in front of only where x is, not the whole equation, but just where x is, and that reflects it around the y-axis. Okay. So here are instructions. Ask us to do this. So A, we're going to graph the following equations. B, we're going to describe so we're going to graph two things. So like in here, we're going to graph f of x, and we're also going to graph f of negative x. B, we're going to describe the translations of the original function from the parent graph. And then C, describe the reflection from the original function to the modified function. Okay. And so I'll take you through that and show the distinction between B and C here. The tables are just for your help. You can use them or not use them. Your choice. Okay. I definitely want good graphs, and but the table's just for your reference if you want to use them. So sometimes you'll see me using them, sometimes you won't. Okay, so I'm already kind of giving it away. This is linear, so you know it's going to make the shape linear because it's in that column. And so I'm going to work on f of x first. So if it's linear, I need a point and I need a slope. And looking at this, I know it's got a translation. That +1 moves us to the left 1. That -2 moves us down 2 units. From what point? From 0, 0. So I'm going to get my first point there. I'm going to move left 1, down 2, and plot that point. And then 3 is my slope. And you can always write that as a fraction, rise over run. So that means from that point, I'm going to go up 3 and right 1. And that creates a second point. So from this point, I'm going to go up 1, 2, 3, right 1. And then I'm going to label this because we're going to put two graphs on here. This is f of x. So next, they want me to graph f of negative x. So when you have negatives and you're working with some kind of reflection, it's either going to reflect across the x or across the y-axis. And if you need to refer to the top, it tells you which one it should be. This one's going to reflect across which axis? The y-axis. And the best way to reflect something across an axis is just to go point by point. So this point right here, so I have 2 points. The point on the y-axis, you can't really reflect it across the y-axis. It's just stuck there, right? But this point here, the bottom point at -1, -2, if I reflect that across the y-axis, you're looking at how far is it from the y-axis. It's a distance of 1 on one side, so I put it a distance of 1 on the other side. And this is a distance of 0, so it stays a distance of 0 from the y-axis. And there's my other function, and that's going to be f of negative x. So that was part A. Part A was to graph both of those on the same graph. Now part B said, describe the translation or translations of the original function from the parent graph. So so this is talking only about f of x, saying, hey, f of x is not a parent graph. How is it translated from the parent graph? Left 1, down 2. That's all you're going to put. Okay. And then part C asked us, describe the reflection from the original function to the modified function. So what kind of reflection was it from f of x to f of negative x? Was it a reflection across the x-axis or a reflection across the y-axis? That's all you got to say. So reflect across the y-axis. Okay, so that's what it's meaning. Those are the instructions that we need to follow. Okay, so let's try this next one, quadratic. So I'm thinking I want to graph this, and I'm thinking, is there a translation? So I'm really doing part B in my mind first, because that's going to help me graph, right? So how has g of x been translated from the parent graph? Just up 3. Okay. And so, and from where? Okay. So up 3 from 0 to 0. And I'm going to do that. So from 0 to 0, I'm going to go up 3. And then how do we finish this graph? When you have quadratics, what else do we need to do? Is there a slope? No, because it's a curved function. It's created by lines, so no slope, but I need more information to graph this. What else do I need to do? You remember how to finish this graph? Yeah, find another point. Plug in a value for x, and so stay close to that vertex. Here's at x equals 0. Maybe try x equals 1. See what you get. So here I'll use this. So if x is 1, I'm going to get negative 2 times 1 squared plus 3, which is going to be, I follow order of operations. I square that 1. I get 1 times 2 gives me negative 2. Add 3, I end up with 1. So I the 0.11. And that's the right side. And that's enough information because there's symmetry. Thinking about my cat right now. And I could put this over here. Right? I got my parabola. Okay. So label it. This is g of x. Okay. And we could also say part B. Part B was up 3 units. All right. Then the other one is negative g of x. So if it's negative g of x, what kind of reflection is that? Let's do part C right here. Reflect across what? Okay. And so you just do that point by point. And so you look at how far these points are from the x-axis and just put them on the other side. So this one's 1 above the x-axis, so I put it 1 below. The vertex is 3 above the x-axis, so I put 3 below. And so that would be negative g of x. Okay. Okay. So let's partner up again, 1s and 2s. And this linear absolute value, if you remember who's 1s, who's 2s? If not, you could reevaluate that. And if you're a 1, I want you to explain how to do this, and if you get stuck, it's okay. But explain what you can do. Explain, okay? So I want to graph h of x and h of negative x. So you're explaining to the person number 2, how to do that. You're not writing. They're the only ones writing. And just kind of working together there, okay? Daniel, I'm making a few. Okay. How'd it go? Did it go okay? Yeah? Did you guys, you or your partner make it all the way through? Something like this? Any questions come up? Okay. And then let's do this one more time. Switch rules. And it's usually the most challenging one is the exponential, but let's give it a try. So switch rules. Let's try the exponential one. So who did the talking between you two? She did the talking? So let's see how we do this. You did the talking. You did the talking. Well, why don't you guys, I know, yeah, it's not going to work out perfect, but why don't you go over here and I'll pair up with Allison.
Okay.
Just to give a little different. And I'll let you guys decide who goes. You both, you did talking and you did talking. So flip a coin. Here you go. That's
All
it.
right. So it's going to be right. Whatever it's going to be. Okay. Right 3 and up.
So right 3. Up 1. Okay. From.
What should I do? From 0.
So
0, 1. So from 0, 1.
it's
So right,
up
1, 2,
up
3.
1.
Up 1. So right here.
Right,
Okay.
right 3. And up
Then
1.
you plug in the X.
Yeah, right 3
0,
and
Y.
What should I plug in?
I'm gonna plug. Yeah, I'm gonna plug it. So that's from 0, 1, right? 0, 0. It's exponential, right? Oh yeah, 4. That's 4. So right 1. Wait, up 1.
And so
Right
if I do
3.
that,
All right. Now what?
That's all I got.
what do we
That's all you
get?
got? You got it. 2. Okay. So now we gotta find some points. So I believe we plug it in. Yep. All right. Two numbers.
Why do we need more points?
So
She's good.
Okay.
1 minus 3.
And we're reflecting it over the x-axis.
Oh, that one.
Yeah, I do.
So help me draw the graph first. I could reflect this. I could reflect
Oh,
this.
3.
Good.
Okay.
So when I reflect it,
So that
across
makes sense
the
anyway, because
x-axis,
then
you
we
said?
have so 3.
So where do I put it?
2 to the 3rd minus 3
3, negative 2.
plus
The
1.
other point
So
at
that's 2
4,
to the
negative
power
3.
is 1. So
Okay.
that's 1 plus 1. That's the point we were
Very
at.
good. Now we need the graph.
Wait, I'm confused.
How do I graph? Yeah, how do I draw it?
I'm so confused. Wait, what?
Well, the first one. You don't go below
4.
0, 1.
2, 4 minus
So do this.
2.
Yeah.
Because we just plotted the point we're at. So that'd be 4, 4.
Like that.
Yeah.
That's the part we definitely need. And then how would I
You do the same for the other one at negative 1.
like this?
Yeah.
Wait, I'm at
You
these.
just draw it like
So
upside
start
down.
0, 1, and we're up 1 again, over 3 here, right?
Good.
So that's the point we just did. That was the 3.
And then
Was the
what would
point
the
we're
answer to
at.
B
That's
be?
3, 2. So if we do 4,
Right 3 up 1.
it's 4. So that's 2 to the 4th minus 3 plus So that's
And the answer to C.
2
Reflect across the x-axis.
first. 2, so that's 4. So that point's 4, 4. So I'll do here. Choose another number.
Good.
Okay.
Let me label these too. We got
5 minus 3 is 2. So
J of
that's
X
2 squared. 6.
negative.
I have really bad handwriting.
All right, so this one, how'd it go? I guess I didn't freeze it so you guys could see it here. Was this a little more challenging? No, maybe. Some of us. Okay. Any questions on the graphing come up? You want to ask about? Okay. Okay. Can I go on to the next one? Anybody copying this down? Yes, I'd love to. So, so if we go back, it all starts with the translation. Okay, all starts with translation. So you want to be able to, from the equation, see that this x minus 3 means, hey, move it right 3. That plus 1 said move up 1 from 0, 1, because we know exponential functions go through 0, 1. The parent graph goes through 0, 1, not 0, 0. So that's your starting spot. Find that point. From 0, 1, go right 3, up 1. And that was right there. Okay? That's the first point. Then you want to get at least another point. 3 is the best, but sometimes with exponential functions, you're just going to have to work with 2. Here I just put 2 on. And when you pick a point, never go to the left because you're going to get fractional values. Go to the right. And so just go to the right 1. And so when we go right 1, that's at 4. And you just got to plug it in. That's what I'm doing here. So I said x is 4. Plugged it in, worked through it. Actually, this is Allison's work, not mine, but plugged it in and got a 3 and got 4, 3. Okay, and so then that gave the next point. But then along with every exponential function, you have to carry that horizontal asymptote with you. And because normally the parent graph has it at the x-axis, but because we moved up 1, it's right here. And so I put that in there, and then that gives shape to your graph. So that's j of x. And then because there's a negative in front of j of x for the other one, that means a reflection across the x-axis. So everything up here, you just look at how far is it from the x-axis on the above it, make it the same distance below. And then you get your reflection. Did that help, Ava? Okay. Which part got confusing? Oh, the flip. So you're good with you're good with the hard stuff. It's just the reflection part. Okay. All right. So from there. Okay, guys. Eventually, here's where we're headed. We're headed towards writing equations of things like this in this unit. Okay, we call it a piecewise function, and it's made of pieces of things. So, like, here's a piece of a line, here's a piece of a parabola, here's a piece of an absolute value, and all three of those together make one function somehow. And that's not today's lesson, but that's where we're headed. Okay, so that's why we want to get good at the individual parts before we start to piece it together. Okay. Here, we're just giving you the function, and we're doing some kind of translation or reflection. And so it's going to be a little easier today. But let's start with the domain and range. Okay, we've seen that. We've written it before in 2 different forms. Why don't you take a minute, write down what you think the domain and ranges of this function. You can't see the numbers? It's going by a scale 1. And write them in both ways, the inequality way and the interval notation. Anybody feel comfortable sharing what they wrote on domain? Yeah, Diego? You guys agree? Okay, and so that's called inequality notation. Okay, and then we can also rewrite this in interval notation. What would that look like? Anybody feel comfortable sharing? Michael? All right, so that's interval. It's yeah, sorry, positive 3, not negative 3. Thank you. Range. This is accurate. This is good. Domain's good. How about the range? Anybody feel comfortable sharing? Anybody new besides Michael and Diego? All right, Chase. Good. And what would that be in interval notation? Square bracket. I like that. To distinguish from the, what would you call the other bracket? Squiggly bracket or something. Eh? Okay. All right. So now we're going to do some modification here. So this right here is f of x. Okay. And if that's f of x, we want to graph f of x minus 3 plus 4. And so we need to know, well, what does that mean in terms of translations or reflections? So what does it mean? We're going to take this and move it which way? Right 3, up 4. That's it. So we're going to take right 3, up 4. And when you translate something, you're really just translating the key points. And so I'm kind of emphasizing the key points here. And so you just do one point at a time. So this point right here, I'm going to move right 3, up 4, and find out where that point would be and put it down here. So if I move right 3, up 4 here, 1, 2, 3, up 1, 2, 3, 4, that puts me at negative 2, 1. So in this graph down here at negative 2, 1, I'll put my first point. For the next point, it's your choice. You could take that second point and move right 3, up 4, or you could look at the relationship between these 2 points and say, well, if I know the first one, I can get to the second one by going up 3, right 3. It's up to you, however you want to do that. And I'll do that second method. So I'm going to go up 3, right 3 from here. And connect those with this straight line segment. And then to get from that second point to the third point, I got to go down to right 2. So I'm going to go down to right 2. And this time when I connect them, I'm connecting with kind of with the curve. And then to go from the third point to the fourth point, I go down to right 2 again. Connect them with the straight segment. And then to go from that fourth point to the fifth point, I go up 1, right 1. And I have my sketch of that translated function. Okay. So just, that's what you're doing, just point by point and getting them to sketch. Okay. And then you're restating the domain and the range. Negative f of x, that's a what? Reflection about the x-axis. Okay, and then you have these two. So go ahead and finish the rest of them. They're not too hard to do, but I'm going to give you a little time to finish those off. You could just do this one. Okay, interval notation. If you want, guys, for domain and range, you could just do it in interval notation. I'm fine with that. Or you could do it in both. Interval notation is going to be the one we fall back on the most. So you could either do both or just interval notation. The other notation. You can do this notation, but also fall back on the other one. Yeah. So for the next two, oh, here's what you want. I'll just show you. And homework's just like this. I'll see you guys tomorrow, okay? If you didn't get a chance to fill out the survey online, please try to get to that, okay?